Good morning to everyone. Today we will discuss the about multiple regression analysis, so which is in the part of second module. So already we discussed about what is regression and what is simple regression also. So we will come to know that what is mean by multiple regression, what is, how it is different from that simple uh, linear regression. So in introduction, see in simple regression analysis, we have studied the relationship between the one explanatory variable and one dependent variable or one responsive variable. Response variable. So here, if there is a relationship between only one independent variable, one dependent variable is called simple linear regression. Simple linear regression. So mathematically, we can write the equation that is called y is equal beta 0 plus beta 1 x1 plus epsilon. That is the error term. See, what is y here? Y is a dependent variable. Beta 0 is a constant or intercept. So beta 1 is nothing but parameter or coefficient. X1 is nothing but independent variable and error term. Error term is also called stochastic term, residuals or random term also we can call. See, in the equation, so there is a relationship between only one dependent variable, one independent variable is called simple linear regression. So we can write an equation like this: y is equal to beta 0 plus beta 1 x1 plus c. Sometimes we can write also y is equal to alpha also, alpha or beta 1 x1 like this. We can write like this. So this is about the simple linear regression. So we have studied in earlier also. So now we look at the situation where there are several independent variables or explanatory variables works together to explain the response. For example, see, we have studied only one dependent variable, one independent variable. For example, when there is a number of when the independent variables are more, what it calls. So here, see, in the multiple regression, there are a number of independent variables are more than one. So itself it says that if there is a relationship between one dependent variable and more than one independent variable is called multiple regression or multiple one dependent variable and more than one independent variable is called multiple regression. So how we can write a multiple regression? An equation, see, that is for example the equation y is equal beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus epsilon. For example, here we have taken four independent variables. See, y is called dependent variable, beta 0 is the constant intercept. So the beta 1, beta 2, beta 3, beta 4 all called parameters or coefficients. Parameters or coefficients we can call. This is called unknown parameters. Sometimes we can call unknown parameters. B's. Then x1, x2, x3, x4 are called independent variables. Independent variables. Epsilon. Sometimes we can write E also. E or U. So epsilon or U or E that are called error terms. So the error term or stochastic term are residuals. So these are multiple regression. See, again I'm explaining that multiple regression is nothing but if there is a relationship between one dependent variable and more than one independent variables. That is called multiple regression. The equations and models or models. For example, how we can write models or equations when we have the different set of data series. So generally we can write general regression model, that is a y is equal to beta 0 plus beta 1 x1 beta 2 x2 plus dot 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 plus bk xk plus epsilon. So y is the dependent variable as we discussed it. Beta 0 is nothing but constant or intercept. So beta 1 beta 2 are called parameters. X1 x2 are the called unknown constants, nothing but unknown independent variables. And what is k here? N number of variables. N number of variables. Sometimes we can take more number of variables at all. That is called up to n we can write it. Instead of k also we can write n. So a is nothing but error term. So the error term are the independent. Nothing but there is no covariance with the error term should be, the sum of errors should be 0 and the variance is minimum. And there is some two types of regressions are there. That is called sample regression function and population regression function. What is sample regression function? The sample regression function refers the relationship between the one dependent variable and more than one independent variables when we have the sample data. When we have the sample data. Nothing but when you're collecting information from the population, that is called sample. For example, if you collect information with regard to their incomes and what are their income determines of the particular street vendors of the farmers' incomes. So when you collect the information from the farmers, so that is comes under the sample regression function. That is called when you're using the sample data, that is called sample regression function. So what is called population regression? PRF, population regression function. The population regression function is called when we have used that population data, when we have the used the total information data. For example, if you take into account, when you take into account that what are the determinants of Sensex and stock market, and what are the factors are affecting the GDP. So these are called macro variables. We can say the macro variables. We can use the population regression function. So in the sample regression function, we can write y is equal to beta 0, so b0 plus b1 x1 beta b2 x2 plus dot 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 bk xk plus e. So for example, when you are estimating the values of the sample observations, you need to put b0, not beta. For sample regression, we can use beta b0 b1 b2 like this. So when you are using that macro variable, you can write y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus dot 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 bk xn xk plus epsilon. So there is a small difference between, instead of b you can use beta. This is not a b, it is a beta. Okay. So here generally we can use this kind of functions or equations or models in the as per our requirement of the. Then there are the data. For example, if you take the cross section data, then we have the what is mean by cross section data? See, when you collect the information at a particular time period, that is comes under the cross section. So when you collect the data at a particular time period, that data is called cross section data. Generally, the surveys, that is comes under the cross section. For example, if you collect information with regard to particular variables in a particular date, there's a cross section data. So in the cross section data, we see here yi is equal to beta b0 plus b1 x1 I plus beta 2 x2 I plus dot 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 bk xk I plus error ei. So when you are using that cross section data in model, you can put I, that is called ith observation, ith observation, ith observation, ith observation. For example, when you're using time series data, for example, GDP and other exchange rate and other factors, if you use, so there's a time series on the base of time in 2000 to 2020. So if what are the factors are affecting the GDP, if you take into consider in the model, so you can take time series on the base of time. Sometimes you can take the time series data, for example, second wise, minute wise, hour wise, day wise, weekly, monthly, quarterly, half yearly, yearly data also you can take. So when you take the data in the time series, you can write the equation like this: yt is equal to beta 0 plus b1 x1 t plus beta 2 x2 t plus bk xk t plus epsilon t. So this equation used for the time series analysis. Time series analysis. It means that, so when you have the time series data, you can write the equation like this. Is it clear? Then for the panel or pool data, what is a panel data and pool? It is a combination of time series and cross section. It is a combination of time series and cross section. So here, for when you are using the panel data or pool data, you can write the equation like this: YTI, nothing but you can you can write here TI is a lower case రాయాలి. YTI is equal beta 0 plus b1 x1 ti like this. Here how we have written ti like this, you can write here also. There is typical mistake only, so don't confuse that. YTI is equal beta 0 plus beta 1 x1 ti plus beta 2 x2 ti plus dot 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 plus bk xk ti plus epsilon ti. That is comes under the panel data or pool data. So when you're using the data panel data, so you need to write the equation like this. So nothing, what is the TI here? Nothing but some time. So in time period, the ith observation, and during a particular time period, the ith observation. Nothing but if you take into account is the GDP, for example, in 2005, there's a time, the GDP value, then ith observation. So in the particular ith observation, Yeah. Then, so is it clear that how we can write an equation for the cross section data and time series data and panel data? Yeah. Then we can move to that next slide. Then estimation of the parameter. So for example, when you are writing an equations like this, when we have the data, how we can estimate the values, the parameters, how we can estimate a beta 0 value, a beta 1 value, beta 2. These are the unknown parameters. We don't know the values of beta 0, beta 1, beta 2. Then we need to estimate. That is called estimation of the parameter. How we can estimate the parameters. So the values of the regression parameters, B's, that is called betas, are not known. We don't know that values. Then we need to estimate the values from the given data series. So as in the simple linear regression case, we use the OLS method. So when we are using that, when you are done simple linear regression, so we use the OLS method. So how we can use the OLS method? What are the methods we have followed to fit the linear function to the data? So simple as like that only we need to follow the OLS method in the multiple linear regression. That is called, say, estimated y cap, here y cap, estimated value of beta 0 plus beta 1 x1 beta 2 x2 plus, so nothing but here it is a estimated function. After estimation of beta 0, beta 1, beta 2, beta up to beta k, that is called estimated function. So when you estimate the beta value, beta 1, beta 2, beta 3, so then only we can write y cap. That is called estimated value. Estimated value. Then the least square method, choose the b's that make the sum of squares. Sum of square of the residuals as small as possible. For example, see, when you are estimating that wireless method, when you are estimating that b's, that is called a beta 0, beta 1, beta 2, beta 3 or beta 4, see, when we are doing that, when you are estimating the beta values, the b's that make a sum of square residual, nothing but whatever we get error values, that error values we should have to square it. So when you are square it, we need to get very less sum of square values of error terms. For example, say how we can get the error value, nothing but y minus y cap. E is nothing. E is equal estimated actual value minus estimated value. So then only we will get error value. So after getting error value, we need to square it. We need to square it. Then only we can add all the square of errors. So in wireless method, what it do? So it will take, it will make the sum of square of the residuals as small as possible. Nothing but when you are using wireless method, the errors, sum of errors should be equal, should be 0. That only we can follow the blue properties. So in the meanwhile, you need to follow wireless method. Just a minute, there is internet problem. Audible now, Shiva?
Sat.
Shiva?
Sat.
Hello, Shiva?
Hello. Sat.
Yeah, then estimation of the parameters. Then, for example, if you take into account in the practical orientation, see how we can use a multiple regression. So, in order to know that what are the determinants of demand. So, generally we studied about the law of demand and what are the factors are affecting the demand. So, generally in economic theory, what it states that the quantity demand for a given commodity mainly depends on price and income. For example, generally in the law of demand, it says that the demand is determined by the so many factors. That's the price, income, price of complementary goods and substitute goods, taste, preference, psychological phenomena also can influence the demand. So there are different factors, different variables which can influence the demand. But if you take into account for the practical exercise only, I have taken the price and income. Price and income which can influence the more on the demand. So therefore, we have the two independent variables, the price and income variables, and one dependent variable, that is the demand. So generally in the economic theory, what we can write equation or function, y is equal function of x1 x2. Only there, just we have taken only two variables. That's why I put it x1 and x2. That x1 is price, x2 is a income. So y is nothing but here demand. X1 is not x1 is price, x2 is a income of the consumers. So this is a normal equation, normal function when we can write in economics. But when it comes to the mathematical and economics model, then we need to write here yi is equal to beta 0 plus beta 1 x1 I plus beta 2 x2 I plus epsilon I. So why I put here yi? I have taken the cross section data. So simple, I have collected information from the sample households. That is a yi is equal to beta 0 plus beta 1 x1 I, beta 2 x2 I plus epsilon. So y is nothing but here demand, because the demand is a dependent variable. So the price is the independent variable. So when the price changes, automatically demand can change. Okay. So that's the demand is depends on the price and income. So that's why I put it y is nothing but here demand, and x1 is nothing but here price of the commodity, b2 is x2 is nothing but income of the consumer, e is nothing but error term. Generally, we can expect the coefficient of beta 1, expected beta 1, nothing but beta 1 is nothing but here, see, there is a coefficient of beta 1, that is a price coefficient. So, do you think that whether the price can affect on the demand is positive or negatively? So generally, we would expect the expected beta 1 is negative, because there is a negative relationship between the price and demand as per the psychological law of demand. The law of demand theory. What it said that there is an inverse relationship between price and demand. When the price increases, the demand falls down. The price decreases, the demand increases. There is an inverse relationship. That's why we would expect that there should be there is a negative relationship between the price and demand. That's why the expected beta is negative. That is the thing that we would expect the coefficient of beta 1 to have a negative sign as per law of demand. So when you are taking into account the theoretical background of law of demand, there should be a negative. There is a negative relationship between the price and quantity demand. And while coefficient of beta 2 expected beta 2 cap to be positive, because there is a relation, there is a positive relationship exists between income of the consumer and demand of the particular commodity. So as the law of demand, when income of the consumer increases, the demand for the goods will be increases. When the income of the consumer decreases, the demand for the goods will be decreased. In case of only superior goods, or some we can say the normal goods. Then before estimation, our simple model, to complete specification of our simple model, we need to some assumptions. So this is the background of multiple regression. But when you are before estimating the parameters, that is the beta 0, beta 1, beta 2, beta 3. So we need to follow a certain assumptions of the random variables. Already we discussed in the previous classes or the previous unit also. What are the assumptions of error term? Assumptions of error term or assumptions of about random variable. That is the u or e or epsilon. We discussed about random. What are the assumptions of error term? Just we can go through them. So these are that assumptions of random variable or error term. The first one, randomness. What is the randomness here? The variable, that is a u, is a real random variable. Real random variable. Nothing but whatever we need to get the error value, that should be the random. That's why the error term is called as a random variable. Random variable. Nothing but unexpectedly it should have to come. Then second assumption, zero mean of u. U is nothing but error term. There is the error term mean is equal to 0. That is a ui has a 0 mean value of each xi. That's because whatever we are going to expect the error value, it should be equal to 0. For example, as we discussed that sum of errors should be 0. When sum of errors is equal to 0, then automatically we get the average of error term is equal to 0. 0 by something is 0 only. That's why when we are estimating the sum of errors is equal to 0, then only we'll get the average of error term is equal to 0. There is a 0 mean of u. That's called u as a 0 mean. That's the expected error term is equal to 0. That's the average. And homoscedasticity. The third assumption is homoscedasticity. The variance of each ui is the same for all the independent variables. For example, when variance of the error term, simple here, almost code is nothing but if the variance of the error term is constant, it is called homoscedasticity. The variance of the error term is not constant, that is called heteroscedasticity. Heteroscedasticity. Homoscede is nothing but if the variance of the error term. For example, when you get the error values, so each and every error term, their variance should be constant. There should not much fluctuations of the variance in terms of variance of the error term. And normality of E, that is the normality of error term. So after getting the errors, when you are plot a normal distribution, that should be randomly distributed. Randomly distributed. Nothing but the errors should be normally distributed. Nothing but bell-shaped curve. When you get the error values, when you plot a normal distribution graph, then the error should be normally distributed. Then we can get the sum of errors is equal to 0, because left side is minus value, plus side is, so automatically when you minus and plus, then you are going to get 0 values. That's why the normality of U is nothing but each every value of UI are randomly distributed. Then fifth one, no autocorrelation. What is no autocorrelation? So no relation between independent variables and error term. For example, see, here, so here autocorrelation means there is no relationship between error terms. Nothing but the previous and for the present error term. If it is not related with that previous error term, it is called autocorrelation. So no autocorrelation, but there is no relationship between the present error term and its previous year error term. That is called autocorrelation. If there is a relationship between the present year and previous year error term, it is called autocorrelation. If there is no relationship between the present year and its previous year, that is called no autocorrelation. Then sixth one, no perfect multicollinearity. So when you are estimating the multicollinearity problem, so there should not be a no perfect relationship between the independent variables. For example, if you take into account in independent variables, what will happen when we are estimating that relationship between the independent variables? Then only we can see that whether the relationship is existing. If there is existing relationship between independent variables, then how much we need to identify. That is called perfect. Whether if it is the relationship is very strong or weak. So as per that Gujarati book and some other economic tuition, they told that if there is a relationship between existing independent variables, that is called multicollinearity. For example, if it is cross more than 0.7, what is it called? Perfect. Nothing but we can say the I or more. We can say that I correlation between the two variables. Nothing but more strong correlation between the two variables. So when there is a strong correlation between the two variables, we can say that there is a multicollinearity problem. So if there is a relationship between the variables that are weak, so we can consider. But if it is too much, we need to delete the unimportant variables from the model. Then seventh one, identification of the problem. So identification of the function. So when you are estimating the function, we need to identify whether our function is good or not. So that is the relationship being studied is identified. For example, on the base of theoretical background only, we need to identify whether which variable is a dependent variable, which variable is an independent variable. So if you consider the dependent variable as an independent variable, you will get bad results. Nothing but you can say that the inferences are not good. That's the good results are biased also. Then eighth one, correct specification of the model. Correct specification of the model. So need to be correctly specified model, that is a linear and non-linear. So when you're writing the equation, so where we should use linear function, where we should use non-linear functions. That's we have to remember as a econometrician or a statistician. You need to be clear which model is suitable for the particular data set. That is the linear and non-linear. And number of equations also. For example, then sometimes we need to write a more number of equations, one equation, second, third equation also. That is called simultaneous equation. We can write sometimes because the y is dependent on x. Sometimes x is also depends on y. So in that case, we need to write two equations. So these are some assumptions of error term which we need to follow when before estimating the parameters of multiple regression. Then after verification, verification of all these assumptions, thereafter we need to estimate the parameters or coefficient of the model. So after verification of all these assumptions, whether we have followed or not, then only we need estimate. We need to estimate the coefficients. So if you are not followed this assumption, there is a violation of error terms, violation of assumptions of error terms. So if you violate these assumptions, you may get biased results. Okay. So after verification of all these values, when you have after verification of all these assumptions only, we need to verify the we need to estimate the parameters. Then, for example, if somebody has given the data on the variables, for example, see, we have discussed only three variables: the demand, price, and income. For example, if you take the demand variable, demand, for example, if I have one person, so if the price of the commodity is, for example, if you take pen, okay. So in order to purchase a pen, the price of the pen is 5 rupees. When his income is 1,000 rupees, how much he is going to purchase? 100 only. For example, sometimes the price is 7 rupees of the particular pen. So another person, if their income is 700, they are going to purchase 75 only. So if the price of the pen is 6 rupees, so another person income is 1200, then he's going to purchase 80. Like this, the price of the pen is 3 rupees. If the person is income is 1300, he's going to purchase 110 pens. What is the demand, price, and income variables? If they are given the data like this, how we can estimate the data? So before estimating that parameters, we need to write an equation that is already discussed, that yi is equal to beta 0 plus beta 1 x1 I, beta 2 x2 I plus epsilon I. So in order to get the beta 0, here how we can find out the beta 0? Beta 0 is equal to y bar minus b estimated or beta 1 cap x1 bar minus beta 2 x2 bar or average of x2. That is called beta 0. So beta 0, once again I'm repeating, beta 0 is equal to y bar minus beta 1 cap x1 bar minus beta 2 x2 bar. Nothing but we need to find the average of y value and beta 1 cap. After estimating the beta 1 only, we need to write here the estimated value and average of x value minus beta 2 value, whatever we get the estimate. Here also estimate, sorry, here I didn't put the cap. Here also we need to put cap. Just a minute, and I will put the
beta 0 plus beta.
See, cap, beta 2 cap, x2 bar. Then how we can calculate the beta 1? So here beta 1 is equal to, open the bracket, summation x1 small a here, small a x1 here, small x1 y, small x1 into y into summation x2 square minus summation minus, open the bracket, summation x2 into y value into x small x1 into x2, close the bracket, divide by summation x1 square into summation x2 square minus summation x1 x2 whole square value. So how we can find out the beta 1 also? Same, beta 2, instead of 1 we can put 2. That is the beta 2 is equal to summation x2y into summation x1 square and summation x1y into summation x1 x2 divided by summation x1 square and summation x2 square minus summation x1 x2 whole square. So whatever I put here, x and x2, that are the small x. How we can get the small x is nothing but capital X minus x, capital X bar. If in order to get the x1, small x1, that formula is capital X1 minus capital X bar, x1 bar. That we can get small x. So please remember this. This is a normal, not a normal equation model. So I have followed the deviation model, mean deviation equation model. The next one, see, estimate the parameters of the model. See, when you are using the wireless model, or that minimize the quantity, that is called sum of error square. We already discussed about that. So in order to calculate that errors, that wireless model can estimate the values that minimize the quantity, nothing but minimize the errors. since formulas of the OLS estimates are complicated, for example, there are so many formulas are there. Not through normal equation also we can get it. So there is a deviation method also we can get that beta 0, beta 1, beta 2 values. Whereas if you take into account, there are number of there's a complicated. For example, there are number of complicated will come, and sometimes we can get and calculation also we can get it. But for example, when you do manually, you will ignore some decimals also. So when you ignore the decimals, some values of the or coefficient values, it may be some different. So we are content to understand the OLS principle and let software. For example, there are different softwares also there to calculate the multiple regression. Excel also, by using Excel also we can calculate that multiple regression parameters, the estimating the parameters of the model. SPSS, the statistical package for social science also. By using SPS also we can get that multiple regression coefficients, and UVs and Stata and R and other software is also there to do the computation. Nothing but in order to estimate the parameters. These are the softwares, and there are other softwares also there. So this Excel is a very easy software to calculate the coefficients of the multiple regressions or estimate the parameters. So simple. Through manually, I am going to explain. See here. Simple. You can remember these equations. Beta 1 x1. See, this is the values y x1 x2. So first we need to find out the small y. Small y, how small y comes? Y minus y bar. Here I put it bar only. So I'm not able to write bar here. So that's why I write in bar. Okay. So y minus y bar, nothing but what is the y value here? Y value is 100. We need to find out the y bar. Y bar comes, how y bar comes? Sum of y by number of observations. So we need to calculate all the values. When you add these 10 values, you will get 800. Then number of how many are there? 1, 2, there are 10 number of observations are there. Then divide by 10. 800 by divided by 10, how much? 80. 800 by 10. You're going to get 80. So that y minus y bar. Y is nothing but 100. Y bar is equal to 80. 100 minus 80 is how much? 20. 75 minus 80 minus 5. 80 minus 80, 0. Like this, we can estimate the small y. Then small x1. Small x1, how small x1 comes? Capital X1 minus capital X1 bar. Same, how we find out the y minus y bar? X1 also, X1 minus X1 bar. So X1 is nothing but 5. You need to find out the X1 bar. How X1 bar? Sum of X1 divided by number of observations. Can you calculate? Sum of X1 is nothing but 60. Divided by 10. 60 by 10 is nothing but 6. So 5 minus 6, you will get minus 1. 7 minus 6, 1. 6 minus 0, 6 minus 6, 6. Sorry, 6 minus 6, 0. 6 minus 6, 0. 8 minus 6, 2. Like this, we can estimate the x minus x1 bar. Then same thing, we need to follow x2 also. Small x2. Small x2 comes capital X2 minus capital X2 bar. So these are x2. We need to find the x bar. So when you calculate all these values, you will get 800, 8,000 divided by 10. So automatic average is 80, 800. So 1000 minus 800, 200. 600 minus 800 minus 200. 1200 minus 800 plus 400. Like this, we can estimate. Okay. Then see. So after estimating that, we can estimate that x1 into y. First one we need to write x1 into y. Small x1 into small y. Small x1 into small y. Here small x1 into y. So small x1 into y. Where is small x1 into y? We calculate here. See, small x1 into y. Small x1 is how much? Minus 1 plus 20. 20 into minus 1, 20. Like this. 5 into 1, minus 5. 0 to 0, 0. 10 into minus 10 to 0, 0. Minus 30 into 2, minus 60. Like this, x1 into y. Then x2 into y also. So here, see, x2 into y. Then we can go with the x1 square and x2 square. x1 into x2 into y. Then x2 into y is, see, what is x2 here? Small x2. Small x2 here 200. Y is equal to how much? 20. 20 into 200. 20 into 200, 4000. Then minus 5 into minus 200 plus 1000. Minus into minus plus 0 into 400, 0. Minus 10 into minus 300, 3000. Minus 3 and 330 into minus 15. Minus and minus plus, then 15,000. Like this, we can estimate. So after calculating this sum of small x1 y, this comes under these values. This is the sum of x1 into y, sum of x1 x2 y. Then here x1 into x2, x1 into x2. Then we can estimate also small x1 into small x2, minus 1 into 200, minus 200, minus plus 1 into minus 200, plus into minus minus 1 into 200, 200, 0 into 400, 0, 0 into 300, 0, 2 into minus 500, minus 10,000. So then we can estimate these values. Then what we have left, x1 square and x2 square. x1 square ఉంది ఇక్కడ, x2 square ఉంది. So then x1 square and x2 square. Here we find out, here x1 square ఇది, not x12, x1 square. So x1 square, nothing, what is x1 here? Minus 1. Then we can square it. Minus 1 into minus 1 plus 1. 1 into 1, 1. 0 into 0, 0. Here 2 into 2, 4. 1 into 1, 1. So here if you take 3 into 3, minus into minus plus 3 into 3, 9. Okay. Then x2 square, x2 ఉంది కదా ఇక్కడ, x2 square అన్నమాట ఇది. x2 square, what is x2 here? 200. 200 into 200, 40,000. Plus 2 minus 200 into minus 200, 40,000. 400 into 400, 16,000. 1,60,000. 300 into 300, 19,000. 500 into 500, 2,50,000. So when you add it, we can get sum of square. This is called total values. So this is the sum of y value, y square value, sum of x2, x1 square value, sum of x2 square value. This is sum of x1 y value, x2 value, and x2 value. So this is a manually we can do it. Simple, you can estimate in the Excel also. Simple, I am going to show that how we can do in Excel also.
X1, Y1.
Say, are you able to see? See, this is the only data. For example, if you take into account, I am going to put it in the second line. This is the data. How we can do multiple regression? How we can estimate multiple regression in the Excel?
Yeah, what
So
about
first we can go to that. There is a dot. See, into data analysis. First we need to go that data. When you click the data, so simply here data analysis. There is some tool icon, data analysis. You can click the data analysis. Then you can get some dialog box. Within the dialog box, we can find out where is the regression. The ANOVA, correlation, covariance, F-test, and histogram, and rank and percentile. This is a regression. We can select a regression and click the OK. Then another dialog box will open. Another dialog box will open. Another dialog box will open. So what is the input y range? Y range, think about depend variable. What is the depend variable here? We need to select here. Only we can select the data. See. Then select. Then input range of x. So here we have the two input, whether the x independent variables. We need to enter 2. Then we can decide here what is the level and confidence level. Okay. Then if you take into account output range or new worksheet, within the you can take into residuals also. Okay, you can take residual plots also. You will get it. Normality of the plots. Then you can click OK. Then see the results, the output of spaces, the summary of output has come out. So simple here, see, there's a multiple regression and R square value, and adjust R square value here. See, as I put it in the this graph also same. See, this kind of results will come. See here, so we got R square value here 0.89 and the adjusted value is called 0.86. Then we will come to know that what is intercept and what is the variable 1 and variable 2. There's the x1 and x2. So here the coefficient values, there's a here intercept is nothing but alpha value or beta 0 value 111.69, that is 111.69. Then variable x1 nothing but the price coefficient value is -7, -7.18, and variable 2, that is called income. The coefficient of income is 0.01, and these are standard error values of the respective beta 0, beta 1, beta 2 values. These are t stats value. There's a t statistic value. There's a, we can say that t value. How t value comes? Coefficient of this value divided by standard error. So if you calculate, for example, I will show you that how t value comes. Simple, t value comes coefficient by standard error, nothing but see 111.6918 divided by 23.53081. Then you will get 4.71746. See, 4.74661. How t will starts? Nothing but coefficient of beta by standard of beta value. Then we will get t value. So why the t values will get in order to get whether the significant or not significant, particular variable is significant or insignificant. So then we will discuss deeply in the next slide also. So here this is a manual how we can find out the values. Easily we can go through that in the software Excel or SPSS, get this value. When you calculate manually also by using this sum of values, you will get this only this values only. The slope value is 111.69 and beta 1 is -7.1618 and beta x2 variable value is 0.01. And the estimation of beta 1 is b1 and it indicates the change in mean response per unit of increase in x1. What is here beta 1 nothing but maybe increase or maybe decrease. For example, beta 1 is nothing but the change in average response per unit change in independent variables. Okay. So when the rest of independent variables are hold constant or held constant. The parameters b1 is frequently called partial regression coefficient because they reflect the partial effect of one dependent variable when the rest of independent variables are included in the model or held constant. Nothing but when other things are remaining constant only, if x1 increases, how much it can impact on the dependent variable. That is the one. That is the demand. Then as I told you that how we can test the significance of beta 1. So before estimating the model, sometimes we need to write a hypothesis also. In the research orientation, we can write a hypothesis. The hypothesis is nothing but beta 1 is equal to 0. That's equal to nothing but the price, the effect of the price is equal to 0. Nothing but the price cannot affect the demand. That is our hypothesis. So alternate hypothesis, the price can affect on the demand. That is the beta 1 is not equal to 0. There is some effect of the price on the demand. And beta 2 is equal to 0, null hypothesis, and beta 2 is not equal to 0. Then now we can test the hypothesis nothing but t is equal to beta 1 bi by standard of bi, nothing but coefficient of beta by standard of beta 1, nothing but whatever we calculated here earlier. Here standard coefficient of by standard error, that is called coefficient of beta by standard of beta value. So reject the alternative hypothesis, null hypothesis if the t value is more than 1.9. This is a thumb rule in the Damodar Gujarat book also. They said that if the t value is more than 2, it is statistical significance. When the t value is more than 1.96, it is statistically significant. So if you not remember 1.96 exact value, you can remember that just 2. Exactly is 1.96. Thumb rule is 2. So when the t value is more than 2, that is statistically significant, and we can reject the null hypothesis also. So the formula is like this to reject the null hypothesis. So instead of this one, you can follow this one also. These are for the t table value. So in order to verify hypothesis, we need to estimate the standard errors. Standard errors. So the standard error is nothing but of the regression provides the absolute measure of typical distance data points from fall from the regression line. For example, when you estimate that regression line, there is a y cap and absolute values, y and actual values, nothing but error values. So when this is a, for example, if you take this is a regression line, for example, if you take only one regression line, so these are the dot points are called actual values. So the standard error shows that how much the dispersion is there between the this point and this dot and this line. How much the difference? This is called standard errors. How much is deviating from the regression line? That is called absolute measure. Absolute measure. Okay, tomorrow we will come to know that how we can test the t test. Tomorrow we'll continue.